In this video, we will continue to design our hinge. In the previous video, we designed the pin. In this video, we will design both plates. We will use the functionality of the SolidWorks to create configurations. So, like you can see in this file, we have a left hinge and right hinge. We will begin by creating a base of the hinge. So we're going to design the part of the hinge that is common to both sides, the left and the right. This is the 2D drawing, detailed drawing of our left wing for the hinge. This is the drawing we're going to use to create our base design. So the base design, which will have all the same features for both left and right wings. Sometimes when you decide to create first sketch, it is hard to decide which side of the part to use to create that main sketch. I guess that comes with an experience, and as you keep designing and drawing, you will find a way to select it. In my case, I will use this view to create my first sketch. We will begin by creating a new part file. You're going to go to File, New, Part. I'm going to click OK. The system will create a new blank part file for us. I don't like the gradient background, so what I'm going to go and do is change it to a plain white. I will also select the front plane. In my View Manager, I'm going to click on the Normal tool to position my front plane perpendicular to my view. With my virtual piece of paper ready, I will start creating my sketch. I could go to Sketch, Create a Sketch, and that would start the sketching process, as long as you have the plane selected like I do. However, I could also go and click on one of the sketch commands, and the system will know to create a sketch entity for me. So let's click on the line command. As you notice in the upper right corner, we have our icons that are used in our sketch, and down at the bottom over here you can see that I'm editing sketch. So I'm going to start creating my hinge by drawing the outer shape of the hinge. So I'm going to click somewhere over here. I'm going to create a horizontal line. Remember that little yellow icon attached to my cursor that indicates that I'm creating horizontal line. I'm going to click over here, and now I would have to create an arc, but I don't have to get out of the line command. I can move my cursor back through the endpoint. It will allow me to create an arc. However, I don't like the way it's bending, so I'm going to go back, and now I like the way it bends. But if you notice, this point here wasn't tangent, so I go through the point again, and it takes a little skill to figure it out, but as you going through the end point at different angles, the system rearranges that arc to be either tangent, bending one way or the other way. So again, that takes a little bit of practice, so be patient. But once I have the arc position and the arc bending the right way, I can go ahead and click to create end of the line. And I'm done for now with sketching my outline. I will go ahead and hit escape on my keyboard. We'll move that arc a little bit down to give myself a little bit more room when I'm offsetting the profile, because this is what I'm going to use. I'm going to use an offset command, which is right over here. I will click on it, and then I'm going to click on my line. A couple things that happen. See that yellow line and arc that's being created? It's a preview for you to show you which way you're offsetting the line and how much you're offsetting it. You also notice that I click on one line and the system selected the arc as well to offset. If you look over here on the offset entity property or parameters box, there are a couple options. So you have add dimensions, which probably should be always checked because you want to be able to go back and edit that offset if you have to. You could reverse, so if you look at that yellow line, it will jump from one side of the line to the other. So you can change your offset side if you don't like what the system selected for you. You have an option of select chain. So see how that arc is being deselected? What happens here, that system will pick all the connected lines. It will save you a lot of work when you're selecting or you have to select many lines. You could offset it both ways. But we're going to just leave one way for now. And there's some other options that we're not going to talk about. Oh, let's try it. Well, let's try the copy. Zoom in a little bit so you can see. So we can create the entire sketch of the side of the hinge by selecting these options. I know that I have to change my offset distance because the design calls for 50,000. And I can click OK. So as you see, there is a offset dimension created, which I could change if I had to, but I don't at this point. What I'm going to do next, I'm going to use my smart dimensions to dimension radius here. The print is showing diameter and not the radius, so there's a little trick that you can use. You can use the system to calculate the radius for you. We have diameter, and radius is half of the diameter. So we're going to put 125. We're going to divide by 2. Automatically calculate the radius. There's one more thing that I want to show you guys really quick. When I design, I like to use 6 decimal places just to be fairly accurate. Right now, I'm just seeing 3. So quick way to change it, we can go to down here to our unit system setting. We're going to go edit document units, and I'm going to change my length to 6 decimal places, and I'm going to click OK. See how the display of the radius and the thickness have changed. The next things, as I am still in the dimension dialog box, I'm going to dimension the length as it is shown on the drawing. I'm going to go ahead and I'm going to type in 1 inch. Now we have most of the dimensions, or pretty much all of the dimensions that we need. So I'm going to exit the dimension dialog box by clicking close dialog box icon. However, if you can see down here at the bottom that the sketch is still not defined. So let's see what happens if we grab that sketch and move it around. Well, it all stays within the proper proportions. However, you can move it around. So this is not the way we want to do the sketch. I really like to work around the center. So I'm going to show you another trick how to put that design around the center of the overall dimensions of this bracket. So I'm going to go ahead, I'm going to go to my smart dimensions. I am going to click on this line here, and I'm going to click on my arc. And I'm going to position the dimension somewhere where it makes sense. I will get a message because, as you see, I already dimensioned that arc, and I'm trying to dimension it again. So system sees that the sketch is over constrained. So I'm going to make this dimension driven. What that means, it does not control this length. It will just display whatever this dimension is. So I'm going to click OK on that. If you look at it really quickly, see this one is, the color of this dimension is black, and this one is grayish. Grayish, it means that it's driven. But that's not the only thing that I'm trying to do over here. I'm trying to find out the overall length of this hinge. So I'm going to go ahead and click on the dimension line. Let me show you what happens if you click on the dimension. Remember, this is driven. This is something that we cannot change. This is calculated by the system. So if I click on the dimension itself, I will get an error message telling me that this dimension cannot be changed. If I click OK, I will get to the same dialog box as I were before. Let me do that again. Don't click if the dimension is driven or reference only. Don't click on the dimension itself. Click on the arrow. Okay, it will save you the clicking on that dialog box. So once I click that, I will go up here to the tab called Leaders. At the bottom, and sometimes you have to scroll depending on your resolution, you will click on Max. And this shows me the overall length of the hinge going this way. So I'm going to close the dialog box for now, and I'm going to try to do the same thing. Going vertical. So I'm going to go to my Smart Dimensions. I am going to click on that straight line or horizontal line. I'm going to click on my radius. I'm going to position the dimension where it kind of makes sense. And here I have the same message, this time showing me a lot more things being over constrained in my sketch. So what I'm going to select, I'm going to make this dimension driven. And I'm going to say OK. See the sketch. And as you can see, the sketch is showing proper dimension and is not over constrained anymore because this dimension is grayed out and is referenced. It's driven by all the other dimensions. Again, we want to change this dimension to show us the overall length of the hinge this way. So what I'm going to do, I'm again going to click on the extension line or dimension line, but not on the dimension itself. So if I click over here, my dialog box shows up here. I will go to Leaders, and I will select here at the bottom the max condition and click OK. Again, that gives me the overall length or overall size of the hinge. Now, like I said, I want to design around the center, and I hope to be able to show you later on that designing around the center makes a lot of sense. But for now, just take my word for it. I will go ahead and I will position this overall length to be exactly in the middle of my origin. In order to do that, I am going to use my Smart Dimensions. I'm going to click on the Smart Dimensions. I'm going to click on the end line. Let me zoom in. I'm going to click on the end line, and I'm going to click on the origin. Now I'm going to position it somewhere where it makes sense. And let me show you first use of equations. So what is an equation? It's a dimension that is calculated by the system using the parameters that you assign. So in order for this to become equation and not mathematical calculation, so if I were to do 1, 1, 1, 2, 5 divided by 2, the system will calculate what is the half distance of this overall length. But if I were to change this, this number would not change. So what I'm going to do, I'm going to click over here again, and I'm going to put an equal sign, and I'm going to click on this dimension. Oops, that didn't work very well. Alright, so I have to double click on that dimension in order to open this dialog box, because apparently this is the only place where you can put the equation during. In order to make it an equation, I have to put an equal sign. This time I'm going to click on the dimension that I want to use for my calculation, and I'm going to add my math, and now I'm going to click OK. And you see the little sigma sign next to your dimension? that means that this is an equation and it will automatically calculate. So if I were to change this to 2 inches, this will become 1 inch. All right, let's keep on going. Let's pick this line and let's pick the origin again. This time, I'm trying to position the overall length or overall thickness of the hinge centered around the origin. So again, I'm going to insert equal sign. I'm going to click on my overall dimension here, and I'm going to divide it by 2. Now look how it's going to shift. Now we are exactly, the overall thickness of the hinge is exactly positioned in the center or around the center of my coordinate system. I'm going to say OK. Now let's see. The sketch is still underdefined, so it means that I'm missing one or more dimensions or relation. Here is what we are missing. If you look at this line over here, let me zoom in, it's blue. It means that it is not defined. I'm going to click escape to get out of the dimension command just to show you. So if I go and I start moving this thing around, I will be able to move it, which I shouldn't if the sketch is fully constrained. So what I'm going to do, I'm going to assign an angle. And again, we're going to use Smart Dimension. Most of the time we use Smart Dimension. We're going to click on this line and this line. And be careful, because depending on how you click it, you might get all kinds of different angles that are applicable. So if that happens, you kind of have to move it around and find the angle you're really looking for. So in our case, this angle should be 25. All right, it looks like the sketch is fully defined. So let me zoom out. Let me clean up my dimensions a little bit. Move them around so they're going to be easy to be seen and changed if need be. Okay, and it's fully constrained. We have all the dimensions, and we can go ahead and close the sketch. Next thing that we're going to do is to create the extrusion of our sketch. In order to do that, we're going to go to Features tab, select Extrude Boss Base, and if we didn't pre-select the sketch, we can select it now. The system will show us a preview of the default extrusion. However, like I said, I like to work around the center, so I am going to use the direction 1 and mid-plane option that will extrude our hinge in either direction. The length of that extrusion will be 2 inches, so if I type 2 inches, the system will extrude our sketch 1 inch in both directions. We're not going to change anything else in our boss extrude command. We are happy with what we can see as far as extrusion. We're going to close the dialog box. Now, to get rid of that sketch selection, we can click on our CAD window, and here is our extrusion. The next common feature of the left and right hand side plates is the corner fillets. We are going to use the fillet command from the Features tab. So I'm going to click on this. The dialog box shows up with all different options. For now, we're just going to select the first one, constant size fillet. In the middle, we will type in our radius, which is 100. So make sure that this window is highlighted in blue. This is where we're going to pick our edges to create the radius. And we can pick multiple edges as long as it makes sense. So first thing, I'm going to pick this edge. Then I'm going to pick this edge. And once again, system is giving us preview of the fillets that we created. Once we are happy with what we picked and with the fillet size, we will go ahead and close the dialog box. The last common feature of our hinge design will be the holes. In order to create the holes, we will use the Hole Wizard command in Features tab. So I'm going to click on Hole Wizard. It will display a dialog box. You sometimes might get that message, but if you click OK, it should be all right. And we're going to really select the simplest hole that there is. So I'm going to select Hole. So I'm going to highlight this icon. I'm going to use inch. And I'm going to use all drill sizes. And I'm going to select 1/8 of an inch. Or you can show decimal values, which will help you if you're not familiar with all the letter grades and fractions. Or you can just simply type in the value that you want. So I'm going to type in 125. For now, I'm just going to deselect, and I have it already deselected, but if you don't, just deselect near side countersink and far side countersink. Also make sure that the depth is all the way through. So through all. Once we're happy with the settings for the hole, and we will click on position here in the dialog box. The first thing the system asks us is where we want to put these holes, or that one hole. We're going to select this face right over here. Then we are going to go to our view orientation, and we're going to click on the normal tool icon that will position that face perpendicular to our view. And we're just going to click without really thinking about any dimensions. We're going to click and place 3 holes. Once we have that, we will go ahead and click on the Smart Dimension. This is just like with a regular sketch. And we're going to assign dimensions. This time we're going to use our Extrude edge to assign the dimensions. So this one is 5/8. This one and this one is 300. And this is 1/4 of an inch. Now we're going to assign dimensions going vertically, 250, 450, and 3/4 of an inch. The same as with the sketch, you will see the fully defined sketch information down at the bottom over here, and this is what we want. I'm going again move around my dimensions a little bit to make them look a little neater and be easier to find and edit. I know we have more holes than 3, we have 6 holes, but I want to show you another command from SolidWorks that can be useful. So for now, I'm going to just say OK here, and the holes were created. Again, the sketches are highlighted, but if you click inside the CAD window, they will disappear. Just on a side note, if you ever would have to go and change the dimensions that you assign to the hole or add more holes, you can expand the hole that you just created, and there are 2 sketches. The sketch on the bottom is the shape of the hole. And you could also open that sketch, edit it, and add some features if you wanted to, if they were not provided in the dialog box. But we're not going to change anything here, so I'm going to exit and I'm going to discard any changes. The first sketch, if you go to edit, it shows you the holes that we just created. And the holes are marked by points. So if I wanted to add another hole, I could go ahead and go to my sketch tab, go to point and place a point somewhere where I want that hole. And I'm going to say OK in this dialog box. I'm not going to dimension this for this example. It's just to show you the flexibility of the system. So I'm going to go ahead and finish the sketcher. Look how another hole appeared. On the same token, if I wanted to remove that hole, I would again, if this is not expanded, I would expand my hole feature. I would right click or left click on the first sketch and I would select edit sketch icon. Then I would go to the point that I don't want, select it, and delete it. So I hit delete on my keyboard. And I'm going to click OK. And this is half of the holes. Next, we're going to use the mirror functionality of the system to create the 3 other holes. So in the Features tab, we're going to go to Linear Pattern. I'm going to click on the little arrow next to it, and I'm going to select Mirror. A dialog box will be open and will ask us for the mirror face plane. This is the plane that we will use, or face, to mirror about. We will go to click on the little arrow here in our feature manager that showed up in the CAD window, and we're going to select the front plane. Once I select the mirror plane, the focus jumps to the features to mirror. If we had to reselect our front plane, I would have to right click and highlight this window. But I'm happy with what I have, so I'm going to go ahead and click on the features to mirror to select my features. And at this time, I'm going to just select the 1/4" holes. And they are, if you notice, they are called 1/4", but in reality they are 1/8 of an inch because we overwritten these in our dialog box. But nevertheless, we have a preview of 3 other holes that are mirrored the front plane. I'm going to go ahead and select OK. And let's go back really quick and look at this here. Why is that a 1/4" and we really want 1/8 of an inch? I'm going to click on the holes and I'm going to click on Edit Features. This was created because we overwritten the size. So we had 1/4" here originally, but we selected to show custom sizing and we type in our own size. In order to correct it, I'm going to go ahead and unclick Show Custom Sizes, and I'm going to find a 1/8 hole size over here on that big list. So I'm going to select 1/8. It did not change the size of the hole, it's still 1/8. The only thing will change if I click OK, we will have the proper designation. So right now our feature states that the hole is, as a matter of fact, 1/8 diameter. Because we finished designing our base of the hinge, so we have all the common features to both left and right plate, we will create our configuration. I'm going to go here up in this tab area here, and we're going to click on Configuration Manager. That will show us a default configuration, which is based on configuration that is created by SolidWorks. What we're going to do right now, we're going to right click and we're going to click on Properties. That will open up another dialog box. We will rename the default to Base. We're going to click OK. Now we're going to enter a derived configuration for the left hinge. I'm going to right click on the base configuration. I'm going to select Add Derived Configuration, and I'm going to name it Left. I'm going to click OK. If you expand the base, you will see that the base is grayed out, but the left configuration has a green check mark next to it. that means that this is the active configuration. We're going to go back to our feature manager, and we're going to start designing the features that pertain to the left hinge. So all we have to do to complete the left hand side plate, all we have to do is create the cutouts. I'm going to use sketch and mirror image for that. So I'm going to go ahead and click on the face over here. I'm going to go to my sketch tab, and I'm going to go straight to my corner rectangle. You see the system did not position my sketch plane perpendicular to my view, which most of the time I want. So I'm going to go ahead to my view orientation and click normal to plane. Once I do that, I'm going to go ahead and I'm going to create the cutout. Now I'm going to click OK on my rectangular command, and I'm going to start constraining my sketch. So I'm going to click on the line, I'm going to hold shift, and I'm going to move over the edge of the cylinder. Well, sometimes it doesn't work, so we're going to try again. We're going to go click on the edge, going to hold shift, and we're going to try to move over the edge. This time I was able to select the edge. Sometimes it takes a little patience to do. I am going to apply the add relation collinear relation. I will put that line right on the edge or silhouette edge of the hinge. And now all I have to do is apply dimensions. So I'm going to go to my smart dimensions, and I know that my width of the cutout is 400. I know that my distance from this cutout edge to the end of the hinge is 850. And all I need to do is position myself vertically. And since my cutout is 400 and I'm designing without any clearance, I know that this has to be 400 as well. If you look down here, our sketch is fully defined now. I'm going to go ahead, I'm going to click OK and finish sketching. The next thing we're going to do, we're going to pick our sketch, just the one that we just created. So we're going to click on it in our feature manager. We're going to go to feature tab, and we're going to select this time extrude cut. Another dialog box opens with some parameters that need to be filled. You see default selection of the dialog box. It will be either default selection or the last selection of the parameters that you selected. Remember, we extruded the sketch 2 inches. The system remembers the 2 inches. But right now, what we're going to want to do is we want to just cut through the hinge. And we're going to go ahead and we're going to use through both ways. Okay? That will assure that if we change the size of the hinge, that this cut will be created through the entire hinge. So I'm happy with what I see. I'm going to click OK. And again, I'm going to click inside the CAD window to deselect the sketch. And here's our first cut. In order to create the other cutout, I am going to use the mirror command. So I'm going to go to my linear pattern. I'm going to expand the menu. I'm going to select mirror. The first thing that we need to select will be a mirror face or plane. So we will try to find a plane or a face that we will mirror about. In our CAD window, we're going to click on the arrow next to the part file, and it will reveal all the features that we have created so far. I'm going to move my mouse over the front plane. I'm going to select this front plane as my mirror plane. The system will automatically jump to the feature selection. If you for some reason need to reselect your front plane, you would click inside mirror face plane and you would select different plane. But we want to select front plane, so let me reselect that. Make sure that it says front plane. Now in the feature manager we have two options. We can either select the cut here, or we can select the feature from the CAD window by clicking on it. So as you see, this cut was listed over here, and again, if we wanted to, we could create multiple mirror images of features. But for now, let's just concentrate on this. Once we're happy with the preview, we can go ahead and we can click OK in our mirror dialog box. This created our left-hand side plane. If you look in our feature manager, you will notice that we have two mirror, which are mirrors around the same plane, and that's very inefficient. You want to keep as low features over here as you have to. So this redundant feature doesn't really work for me. So what I'm going to do, I'm going to go ahead and I'm going to delete the mirror image that we just created. I will get a message asking me if that's what I really want, and if there are any dependent items, they will be listed here. But for now, I'm just going to say yes. That will delete only the mirror of the feature. What I'm going to do right now, I'm going to click on the mirror one, click and hold it, and drag it past my extrude feature. You can see it positioned, the mirror was positioned at the bottom of the tree. So right now I'm going to right or left click and I'm going to select edit feature. Now I'm going to make sure that my feature to mirror selection box is highlighted, and I'm going to pick the cut. This time I'm going to select it from the feature management tree. So look at the preview. Now we're going to be creating mirror image of the holes as well as that of the cutout. So I'm going to go ahead, I'm going to click OK in my mirror image command, and look at it. We have again our left hand hinge, but this time we're using mirror image to create mirror image of multiple features. Now it's the time to create the right hand side of our hinge. We are going to go to the configuration manager and we're going to double click on our base. That will bring us to the design that is common to both right and left plates. I'm going to right click on the base plate configuration. I'm going to add the right configuration and I'm going to name it right. Once I do that, I'll go back to my feature manager. Now I am ready to design my right wing plate. As you see, the cut extrude was suppressed. It's grayed out and you cannot see it in the CAD model. We will go ahead and create the sketch now for the cutout that is unique to the right wing plate. We could go ahead and sketch that would be used to create the cutout for the right wing plate. However, I want to show you a little shortcut and maybe a little bit of a streamlining technique. We are going to expand our cutout here, and even though it's grayed out, we can still select the sketch. We are going to select the sketch And on our keyboard, we're going to press Control C. Then we're going to select the face where we want to place the copy of that sketch, and we're going to click Control V. That will create a copy of the sketch that we already created. I am going to position my view or my part so I'm viewing straight down on it. And I'm going to go ahead, I'm going to edit my sketch. The sketch was placed somewhere arbitrarily in the CAD window. However, we already have the sketch created. All we have to do is add constraints. So what I'm going to do, I'm going to click on this line. I'm going to hold Shift, and I'm going to click on the edge of this hinge. And then I'm going to select collinear from the available relations. The next thing that I'm going to do, I'm going to, without holding Shift, I'm going to click on the line, and I'm going to hold Shift on my keyboard. I'm going to click on the edge of this silhouette, which is not working again. So we have to get a little bit closer. We might have to zoom in to be able to select the silhouette. Alright, didn't do it. So I'm going to deselect that. So I'm going to hold Shift, click on my line, and I'm going to select the edge, silhouette edge of the design. And I'm again going to select the collinear relation. That put the edge of this cutout right on the edge of my hinge. Now all we have to do is add the smart dimension for the depth of the cutout. So remember, that was 850. Our sketch is fully defined. We can go ahead and close it. Now we are ready to extrude. We're going to select our sketch. We are going to select Cut Extrude. The dialog box will open, and again we will select through all both sides and click OK. That created our cutout. So again, I'm going to look at it straight down just to see what's going to happen. And I'm going to use another feature of SolidWorks, which is linear pattern. So I'm going to select that. It's already here up on the top. So I'm going to click on that. I will be asked for the direction of the linear pattern. So I'm going to click on that line. I'm going to make sure that my arrow is pointing down because that's how I want to copy this feature. If it's not, you can always click on this icon over here. It will reverse that arrow. So if you look up that arrow and you click, it will reverse the arrow to the direction that you want. The next thing, it will ask you for the distance, and since the length of that hinge is 2 inches and we have 5 total sections but only 3 over here, we will skip 1 section, so we're going to go times 2, and should be able to see a preview. Not sure why it's not doing it. Oh, okay. It's not doing it because we never selected the feature. So we are going to click in this box over here where we select features. We are going to go to the little arrow over here, expand our feature manager, and we're going to click on our second extrude. That will give us a preview of what we're doing over here. So we're going to say okay because we're happy with what we have. And there you have it. You have the second or the other hinge plate design. Let's go back to our configuration manager. We're going to click on the base, double click on the base. Will show us the base design. We're going to double click on the left. It will show us the design for the left plate. We can double click on the right and it will show us the design of the right hand plate. Don't forget to save.